Right. Is it changeable, right?
Yeah, it is changeable. It's blurred, maybe due to network. 1 minute, 1 minute.
Yeah, it is for yeah. It
Yeah,
shows
now it is fine. Now it is fine. Now it is fine. Can you change it?
Yeah.
Yeah. Yeah, now it is fine. Yes.
Right.
Change it again. Yes. Yeah, now it is fine. Yeah.
Right. Right.
Okay, sir. Okay, sir. Thank you, sir. Fine, sir.
Yeah. Fine.
Thank you, sir. Welcome to 1 week online FDP.
Yeah. Thank you, sir. Thanks for this opportunity.
Yes.
Like completely visible, na, sir? Right?
Yeah, now it's okay. So when you start your presentation, please make it as a full screen, sir. That's
Yes,
more
sir.
than.
Yeah. Fine.
We'll start at 11 o'clock, sir.
Right, sir. Right. 20 more minutes is there.
Yes.
Just I'm stopping my video and.
Okay.
Subramaniam sir, am I audible?
Yes, ma'am, you are audible. Yes, madam, you are audible.
Okay, sir.
Ah. Sir, shall we start, sir?
Yes, sir. We'll start, sir. Arun Mehta.
Shall we start, sir?
Yes, sir.
Yes, madam. Yes, madam.
Good morning to one and all present here. I welcome you all for the 6th day of our National FDP on Advanced Computational and Experimental Research in Physics. The 6th session will be handled by Dr. Arun Mehta, Associate Professor, Department of Electronics and Communication Engineering, KLEF, deemed to be University, Greenfields, Vedeshwaram, Guntur District, Andhra Pradesh, on the topic of energy harvesting technologies for IoT. Now I request our Professor Dr. M. Dhanashekaran, sir, Assistant Professor, Department of Physics, to introduce our chief guest. Sir.
Thank you, ma'am. Very good morning, everyone. I welcome you all for this day 6 one-week national level FDP on Advanced Computational and Experimental Research in Physics. It is my privilege to introduce Dr. S. Arun Mehta, Associate Professor in the Department of ECE, KL University, Andhra Pradesh. Dr. Arun Mehta has obtained his PhD degree in the year 2016 from Anna University with the CSIR SRM Fellowship under the guidance of Dr. V. Rajendran. Soon after, he joined as a SRB National Postdoctoral Fellow at Anna University under the mentorship of Professor Dr. R. Jayawal, sir. He has expertise in nanomaterial synthesis and characteristics for solar applications, Currently, Dr. Arun Mehta is working on nanomaterials for energy and environmental applications, and he has published 35 research articles in highly reputed journal, 6 paper in conference proceeding, and 2 patent as well. He has organized many international conferences like Nano 2010 and MAM 2012. He guided 6 MTech students for thesis, and currently is guiding 3 PhD research scholar to develop a new material and implant the devices on the Internet of Nano Things. And he recently received a DST SERB Teacher Associate Fellowship for research excellence in the year 2021 to 2024. Now I request Dr. Arun Mehta to deliver his presentation. Sir?
Yeah, thank you, sir. Thank you, Dhanasagar, sir. Thank you, HOD, sir, and the management of SRM, and to giving this opportunity to share our works, which we are currently working, and then the required technologies to be the upcoming days. Thank you, sir. Thanks for the nice introduction. Is my screen is visible?
Yes, sir. The screen is visible, sir.
Yeah.
Yes.
Yeah.
Yes, sir. It is visible, sir.
Yeah. Today we are going to see just a few things on IoT. What is an IoT, and what is the challenges and the methodology of energy harvesting techniques. So these are all the new technologies which is be required for IoT devices, thermoelectric, piezoelectric, RF, and other things. So now we'll see one by one, just as a introduction part. The end of the presentation, I hope you will get some the valid informations for your R&D and the utilizations to be the next level. So you'll get some ideas. We'll end of this presentation. If you have any queries, you can ask me. If you have any queries in between, also you are most welcome. So first of all, what is an IoT? So the current technology is like everybody is saying about Internet of Things, Internet of Things. So first of all, what is an IoT? So simply we can say that the connected device, every devices can be connected over IP with interact with the predefined logic. Now the strategy is also changed. Apart from predefined logic, it is going to be the artificial intelligence and machine learning also, and coming into this IoT. So how it is to be working? Earlier, the machine means like the people has to perform the task. Now what happened? The machine, like the people, the next level it goes to the people to the machine, the one interactions. Nowadays it is going into the all the levels, like people to machine interactions is also happen, people to people interaction, even the machine to machine interaction also happening. So it means that without human interface, the machines or instrument or the device can be communicated each other. Not only communicated, it can be controlled also. So this can be happen, right? So in this, what is happening inside? So what are all the overall things? What are all the major things to be required in the IoT locations? Like first, device connections and data sensing locations and communications and data analytics, data value, and human value. It means that so the machine will sense the data and it communicates through wireless or wired, and data to be analyzed, and whether it is to be required or not, it will take the whole decision and finally given to the outputs. So with all, like in fraction of second, it is to be performed, right? So how it is to be growing? So in earlier days, very minimal device, it is to be available as an IoT device. Now it is keep on increasing. Now the billions of devices are connected. When compared with the human populations, it is 5 times, 6 times now up after COVID. Not only like before COVID, I don't know, like it will be like the projected in the 2025, if it goes means like it may be like 9. But after COVID, the technology scenario is completely changed. Like as we are we may think that every FDPs or faculty development programs earlier before COVID and all, it has to be the offline. Now we are in the remote locations, and we are sharing our knowledge and we are sharing the thoughts easily through internet. So that is what this the COVID scenario is changed it completely. The predictions is increased to double the time, even triple the time also increased. So like for comparison, you think about we are following that the existing the parking things, earlier things. Now how the thing is converted in smart parking, right? So even the traffic signals nowadays connect completely operated from the remote locations. Like earlier, it will little bit difficult. So now it is at the next level. It is to be user friendly, user accessible. It's just for example, it involved in many of the fields like medical, wearable, like assert, and even in smart home. The multiple angle in all the angle, the IoT thing is to be developed. So the thing is, when the technologies are grown, we are supposed to be face the many challenges. We are ready to resolve, like we are ready to provide the solution for the challenges. So many challenges are there for IoT developments. So like testing and updations, like obviously the data security is most important, software complexity, data volume. These are all the challenges. And as a like electronics engineer, as a materials like working in that field, I'm working past 10-15 years. So my point is like how to provide the power. The power thing also the major thing. Like we are not able to provide the continuous power supply to the devices. It is very difficult. This is the major challenges. I want to give you like how it is, what are all the technologies to be provided to overcome this challenge, right? So the like in depth, like we know, as we said, like in 2025, not only the billion, 1 trillion, or it may be the 5 trillion devices also to be goes into the connector to the IoT device. All need the power source. The power is the most important thing. The thing like, so how we can provide the power supply, right? So before entering into the topic, we'll go with that existing power technologies. So many people are saying that the different technologies are existing now. We are conventionally utilizing the power sources. People are saying many, but like only two techniques. One is rotating electric generator, another one is photovoltaics. I could say only these two techniques we are existing, we are utilizing. I'll show you that how it is to be. First, we'll see one by one how this electric generators. So in electric generators, we know that the magnetic coils N and S is there. When the coils is rotating, when the flux are cut, the EMF will be generated. So the output is we are getting it as a power. That is what the generator. So the thing is, this is the basic on the electric generator. This is to be utilized for all other methods, right? We'll see. I'll show you that next slide. Now you can see that nowadays the people are saying that renewable or non-renewable and many techniques we are saying, right? But the only thing is the source is changed. The method is changed. That the technology what we are using, the generator is same. Like you can see the coal. So what we are using in the coal, so it is to be fired and then water has to be make it as steam. Then the steam is used to rotate the turbine and the turbine is connected with the generator. We are getting the power. So oil also the same technology, gas also the same. The nuclear power also, then the heat will be generated. By that, the steam is generated, the wind is rotating. These are all the fossil fuels. When coming to the renewable energy sources, also we are in the same hydro waves. So because of there is no steam generation and all, because of the hydro waves, this turbine is rotated in attached to the generator, then the power is generated. So the next that we'll see the before going to solar, we'll go to the wind. Wind also the same. So because of the wind and wind, the turbine is rotated, we are getting the power. Sir, how about the solar, sir? Earlier you are saying that two techniques, one is generator and solar photovoltaic. Here in solar, we know that two resources are available. What is that? One is light, another one is heat. Now here the heat energy is utilized. The heat energy is utilized and it is converted into the steam and it is to be utilized for the generator. The another source of the solar is the light energy. That is for the solar photovoltaics, right? So I hope you are you got the point of the existing power generation process, right, which we are utilizing now. Now what we are going to see is the IoT devices and all. It needs very low power supply, not like the laptop, not like the GSM or whatever it is. It needs very low power supply in the value of microvolt and nanovolt supply only is required. Done. So only it requires the very minimal power supply. Then why to depend on the conventional power sources? We can go with the new technologies. So like the when IoT comes, all our wireless technology, the data, like now we are require those kind of things only, right? Like the whenever you are feel that safe and comfortable, that you will say that you may use that IoT technology or latest technologies. Nowadays, no need to connect the headset also. Even Bluetooth headset we are using, right? So like all the data are connected into the wireless, but why to depend the wired power supply? So this is to be need to be addressed. So for that, we are existing technologies are available: photovoltaics, piezoelectric, thermoelectric, right? So even radio frequencies also can be utilized for the power generations, right? So I have picked only the 4 techniques. One is RF, vibration, thermal, and photovoltaics. It is to be utilized for the millivolt to the microvolt and nanovolt, right? It depends on the area of the device which we are using, right? So now we will see one by one. First, we'll go with the light, thermal, vibration, and RF. Right. In this, we could see that it is having 2 different things. Like one is like in light, indoor and outdoor. Obviously, we know that we are well versed in that solar photovoltaic techniques. So in the outdoor unit, we are getting the more light energy. Then obviously we'll get that power supply of more than 1 milliwatt per centimeter, like 1 milliwatt in the indoor, but outdoor more than that, 100 to even 1 volt also is possible. Then vibrations, it depends. So human generated vibrations is less than machine generated vibration is high, like that. So existing, that means existing environmental energy is to be converted. It is to be utilized for the to running our the IoT devices or upcoming the technology devices, whatever it is. It is, I am not going, we are not saying that we are going without the battery. Batteries also is required. We are not saying that we are going to replace the battery completely. So to recharge the battery, we are going to utilize the existing environmental sources. So these many techniques are available. We can see that in the environment, energy sources are available in the plenty. So only thing is how the technologies are utilized for the conversion of energy sources. Even the more amount of mechanical vibrations are there because of the waves or because of the wind, like because of the movement, like we are getting, and radio waves. Even you are, except if you are not in the vacuum, then other locations you can see that the enormous amount of radio waves are there. So in the radios, what happen? The radio waves are converted, and inside the device it is converted into the data. We are receiving the data as a signal. Now, apart from that, if you are having that conversion devices, then you can convert, make use of the retina, you can convert that radio waves also the power supply. Solar photovoltaic, it may be the artificial lightning in the sense like the light source, like existing light source or the solar radiation. So like that, in the environment, the plenty of energy sources are available. So what is the required? What is the major things? The conversion techniques. After that, the next block is the most important block is interface circuits and power conditioning circuits. Why it is required? Because we are not getting in the regular conventional power supply. It may be regulated power supply you are getting, but this you are converting the unregulated, right? So it should not damage the device, or like we can see that in the solar, more amount of current, less voltage you will get, and in the vibration, more voltage, less current will be there. So we need to balance the things. So that is why we need to concentrate in these technologies. The power conditioning circuits also required. So it is connected to the batteries also. But as I said, I told we are not going to completely replace the battery with the environmental power converter. With this, we can store the energy, and it is to be utilized for our sensors or actuators or IoT devices. This is in these blocks, we are having the enormous amount of research locations. The people can work on this set of energy harvesters or this particular power conditioning circuits, or in the next location of utilization side. So we are having the enormous amount of research, and then upcoming technologies, required technologies are required based on the developed devices. So we'll see one by one on just like glimpse the photovoltaic. The name itself, we know that photovoltaic, like photon is utilized for the conversion of light energy to electricity. So like in the PN junction, if you are connected to the PN junction, the freely available of electron and holes, because of the light energy, it making into the move, and we can collect the electron and holes. Like this is, once it is closed, then we are getting the power supply. So this is the simple mechanism. So in this, we are having the different structures, like the top layer N and P. Why we are reducing the top layer? As we know that like the light energy cannot, the light interaction should be happen in the depletion region. So that the point is there now, in that depletion region location, it is need to be reacted. So in order to enter the light easily, and it is the reaction has to be happen in this particular location. So top layer is very minimal and bottom layer is thick. Like so, this is what the cross-sectional views of the photovoltaic cells, right? So I think in next like small animation, you can understand that how this complete photovoltaic cell is to be working. Is this video point is visible, or only the PowerPoints are for the audience? Please, anyone?
It is visible.
Yes, sir. The video is visible, sir. If you play the video, okay, no problem, sir.
Yeah.
The photo.
Yeah. So this is what the solar structures. You are seeing that cross-sectional view. Right. You can split it into that top contact, bottom contact, N layer, P layer, and then depletion layer. So this is what the cross-sectional view. photovoltaic cell structures. So in an each and every cell is we are having that need to be assembled in series and parallel combination. It depends on your power requirement, right? In this, different types also there, right? So single crystal, polycrystal, and amorphous. In the silicon cell itself, we are having the wide variety of the things. It is, if you are having high purity, you will get the high efficiency. But to making into that high purity of silicon, the expensive to make. So then that's why we are going with, depends on the location. If you are not cost dependent, you need the only power, you can go for single crystal. If you are need that location is high, is that the cost wise you want to get, then you can go for the cheaper to make, like so polycrystalline 12 to 16%. The amorphous silicon, it needs the large surface areas. It is to be making to be very simple, and it is to be utilized for the flexible also, but the efficiency is 4 to 8% only. So apart from the silicon, we are having the enormous types of solar cells. It is from that beginning, like thin film solar cell, and that emerging technologies of dice, and the next is like now the currently the people are more concentrated on the ferrostates. These solar cells are also, this is what the chart with, this is like every 6 months the NREL peoples are like releasing the charts. If any breakthrough in the efficiency, if any breakthrough in the efficiency of the solar cell, then they will quote this, they are quoted, right? You can find that like normal solar cells is not going beyond the 25. So then how come it is 47 and all? These and all, you can see that it comes from the multi-junction solar cell or the concentrated solar cells. So it is varying. The concentrated solar cell means like we are not in that, it is materially stable, good, but the concentrations, one sun, instead of one sun, or they are going to send that 2 sun, 3 sun, 4 sun. So they concentrate the things and they are making, right? So the existing, the theoretical and like the practically we are reaching that around 23 to 25 only, right? So depends on the, these are all the different charts. You can go through the website, you will get the complete details of the best efficiency solar cells, which is the institute or which research institute or breakthrough the efficiency, right? So like now coming into that our solar energy harvesting. So as we know that the outside solar cell is can generate the more power, but in the inside light is very less. But that is sufficient to run the wireless IoT devices, right? This is also like you can monitor whatever the room condition, not only for household appliances, it can be utilized for the industry appliances also. So this is sufficient for the these multiple kind of wireless technologies, right? So in the solar panel applications, not only for that IoT devices, apart from that, it is to be utilized in the multiple ways. Like most of them, we can see this is like the calculators. It is like it can be work, even the batteries are gone, then you can in the sunlight you can work. This is to be not only in the sunlight of outside environment, inside environment also sufficient to run the calculator. This is what that first maybe the role model for the researchers to generate the power. You can be utilized for all kinds of devices also. So the next thing is technology is thermoelectric. This is very simple things, but it is invented in the earlier days. But now the peoples are start thinking and utilizing these technologies also, thermoelectric power generators. This thermoelectric power generator existing in that like conventional power sources, but it can be utilized for our regular also. It is like in watch kind of things also it can be. Here also what is utilized? PN and N junction, because of hot and cold, that because of the temperature difference, the movement of electron is happening. The moment that electron is utilized, that's it. So like the thermoelectric energy harvesters also can be utilized. So I want to for better understanding, you can see this also, how this thermoelectric, the cross-sectional view. So because of the temperature difference, the movement of electrons are happening, then it is utilized for our devices. So it is very minimal amount of power. So it is sufficient for the devices of IoT devices or that small automatic devices. So, but the thing, what is required as like solar cell, the small unit can generate the can harvest the energy, but it is to be assembled. It is to be assembled in a series and parallel combination. Depends on your power requirement. It can be connected on series parallel combination of series and parallel combination. Then the what is one more thing is required. It is to be supposed to be having in the flexible environment. The people are more concentrated on nowadays on flexible, not only on solar cell going to the flexible, on all the technologies, like because of the convenient, we need more and more convenient devices. So the basics research or the basic things also need on the flexible part. So various 10 energy harvesters are there. These are all just for an example. If your time permits, you can go through this paper. You can. This is the reference paper which I received from the internet for my work. What I have referred these journals. So the next energy harvesting thing is piezoelectric energy harvesting. We know that like piezoelectrics, when the electrical energies are given onto that piezoelectric material, it generates the vibrations, right? So the reverse wave, all in the reverse wave. The previous things also same. If you are giving the power and with that the devices, you will get the heat energy or cold energy or both you are getting. The similar way in this also, the vice versa. If you are providing that current or power supply to that piezoelectric, it will generate the vibration. Then the same, the vice versa. If you are giving that vibrations, in that vibration, then the power will be harvested. This is what the piezoelectric energy harvesting. This is the people wants to make it in the next level. So that's why the peoples are utilized. This is to be in the next level of triboelectric energy harvesters. So like in the, this is what that piezoelectric structures, the same that kind of PN junctions structures. Just if you are like the mechanical things, the piezoelectric, if you are stretched and added, because of the stretch, electrons are released. Then again, if you are released, then it is coming into. So it will be. Let us assume that small leaves. If this leaf is moving into that air, that is sufficient to monitor your home environment, whether how the temperature is there or not. So like, so just you take this as an example. This is to be the combinations. So of solar, wind, and then piezoelectric. So like nowadays, that is also the most important. We cannot depend on the single sources of solar or thermo or piezo. It needs the combination. In upcoming slide, I will tell you those things also. So this is are the different forms of piezoelectric energy harvesters. So next thing is the triboelectric. So the triboelectric is having in the two different things. One is vertical and slide. So in this, we are having the thing is like utilized in that multiple ways. That is called that multiple ways in the sense one is fixed, another one is movable, right? Whether it is to be utilized for single electrode mode or vertical contact separation mode, or linear sliding, or freestanding. In that, in the image itself, you can better understanding of freestanding in the sense, like the movement of electric wheel, that tire is there, no, that is one electrode, then bottom is the device. So you move by movement of the like the wheel on the electrode, also we are getting to the power. So linear standing, it in the sense like linearly move on the surface, that both the contacts are attached. So that is single electrode, one is movable, one is fixed. So like that, this is also like, if you are, while you are step walking, that the pressure is applied and released, then the power is generated. Then you can utilize this power while you are going walking. Then you can recharge your mobile also, or your earphones, or whatever the devices which you are having, the low power devices, it can be chargeable, right? This is like you can.
Deep in the forest, a sensor monitors the occurrence of fires. There is no electrical supply and there are no solar panels, and yet it is self-powered. The secret lies in triboelectricity, that fundamentally takes advantage of static electricity charges to generate energy. Thus, any movement generates a electric current thanks to the transfer of electrons from one material to a compatible one. This allows multiple devices to be powered. But the latest research has multiplied its potential with the arrival of triboelectric nano generators. These properties are integrated into devices such as this medical patch that monitors the heartbeat. Thus, a substrate with a layer with triboelectric properties in contact with an electrode generates electricity. This glove, these nano generators can also be integrated into domestic elements such as this wooden floor. By stepping on it, it detects the presence of people without the need for an electrical connection, and it allows the activation of IoT devices automatically. But triboelectricity could also power a new generation of wearables, such as smart shoes or socks, to monitor physical activity. Any material has the potential to become a generator of renewable and clean energy.
Hope you just understand about that, how these tribo nano generators are work. Here also, like multiple nano generators are designed based on the appliances, based on the utilizations. The people are designed. The thing is like which movement can be utilized. So if you are utilized in the heart, then it may be required in the ball shapes. If you are like utilized in the shoes, then this kind of vertical shape is required. If you are utilized in the wind, then this kind of rotary design is required. So everything it is to be depends on the applications. The variety of designs can be made, not only for the optimizing the power or the things, depends on the applications. The designs also vary. So the next most important thing is RF energy harvesting. We know that like RF energies are utilized from the radio wave communications, but the upcoming the power requirements are day by day increased because of that. More and more devices are increased, as we said in the earlier, right? So like how it is to be in that impedance matching circuits are available. So this is to be the convert that radio into radio waves into that power supply. That is to be rectifier is required. So each and everything, like in the solar, we can get that DC signals. And the next thing is thermoelectric DC. Then in the triboelectric, it is given it as an AC supply. So here also like AC supply, then we need the rectifier and then voltage multiplier. then before applying into the appliances or the power backup, the power management circuits also are required. So it is like very minimal amount of energies are available. This is more than sufficient the remote location. Let us assume if you are having the devices in that sea monitoring, like whether at the border crossing location or wherever it is, to monitor the environment and monitor the security purpose. What is the required? It can be worked for 1 year or 1.5 years or 2 years. The battery need to be replaced. But if you are fixed with these kind of devices, then it is to be no need to replace the battery. The RF energy is also to be utilized. So in that location, whether it is RF is alone is sufficient or any other, we can think of it. It may be that remote location RF energy is very, very less, but the sunlight is very good. Then we are going to utilize the sunlight. So something like depends on the applications we can utilize, right? So we'll see that how the RF energies are utilized.
Researchers from the Massachusetts Institute of Technology created a rectifying antenna, or rectenna, using a thin molybdenum disulfide semiconductor that's only 3 atoms thick. Electromagnetic waves like Wi-Fi are captured via the device's radio frequency antenna and then converted into direct current. The rectenna produced 40 microwatts of power when exposed to typical Wi-Fi signals of around 150 microwatts, enough to power an LED or silicon chips. According to MIT, early applications for the technology include flexible smartphones and wearable electronics. The device can also reportedly be used to power medical implants or swallowable sensors in place of traditional batteries, which can leak lithium and be lethal to patients. Due to its flexibility, the device can be fabricated to cover large areas. Researchers believe it's possible to develop electronic systems that can wrap around highways, bridges, or office walls.
So this is what that different structures of antennas also to be designed by the peoples, like in this multiple devices also to be attached. So as we need to assemble the cells into the panel kind of things, as like the solar, the small units for that receiving the better outputs. We are need to be have it in the cell kind of things, small unit cells, and it is to be assembled, right? So as like I told in the previous things, so depends on the location, depends on the application. These technologies can be merged or hybrided with the multiple sources or like single sources. Let us assume that as I said, like in the C locations, maybe the RF is energy is very less, but in that location, light energy, the solar is coming in the proper way, right? So then you can hybrid that power. But in the middle of the sea, the wave may be very less. But if you have the same devices in the corner of the device, if you are using like that seashore location, then what will happen? That waves also it can be attached. In the waves, only on with the wind, or if you have the wave location can be attached with the tribo-electro winds. So if it is that is the case, then with this small designs can increase the more amount of power. So like that, the hybrid or multiple sources can be utilized for complete power requirement can be fulfilled of the wireless sensor devices. WS and wireless sensor network devices can be fulfilled with these energy harvesting sources itself, right? So these are all the few examples of hybrid multi-sources which can be integrated for the complete energy harvesters. So this is the just for the applications. So how it is to be merged? Piezo and photonics may be merged. Piezo or like other things can be merged. Optoelectronics can be merged. Then these are all the energy harvesters application. Nowadays, the peoples are the mainly focused on the power also in this while making in that enormous amount of devices or systems are utilized in that highways. That so that's what most of them are required. The while you are working in this field, what is required, like how it is to be industrialized. So wireless and smart self charging capacity may be increased, environmental friendly and cost effective materials, and flexible and smaller in size. The most important thing is flexible, also most important, right? That enhance in the energy and power density. It means that depends on the structures or designing in the combination of series and parallel combination. And most important thing is longer lifetime and the compare with the product lifetime. So like it is needed, it not need the better results within 1 year or within 6 months or within 2 months. If it is destroyed, it is no use of the longer lifetime. So these are all the things the people who are working in this area need to be concentrate on. Like, so as we are, like, it is not the existing, like this is the latest technology alone. The people, these are all the companies are already started utilizing the things, and only thing is few things are commercialized already, few things are not yet commercialized. So like the energy harvesting sources, so the solar based or vibration or thermoelectric, commercially available, these things, the vibration and all, the prototype and pilot plant only it is available, commercially it is not yet happened. So this will give you the glimpse whether this techniques is commercially available or not. Like what are all the piezoelectrics are mentioned in the green, right? Widespread production is there, and then orange things. The still the more many researchers are going on, and the red thing is major trials are going on. So you can see that thermoelectric and photoelectric and then piezoelectric. These are all mostly commercially start utilizing the field, and then pyroelectric and radio frequency waves, and then the triboelectric. These and all in still in research, and it is the major trials are required before commercialization in the product. The great research or whatever the thing is, what is required, it is started with the basic research, the next technological research, and then pilot line, and then mass production is required. The research like nowadays we are, earlier we are in this location alone, but now because of that like institute or government supports, continuous supports on research, the peoples are moving towards that technological research with the collaborations and then pilot line and mass production. that is the thing. You can see that even in the like project sense and the ratio also. If you are earlier, if you are doing the basic research, they are giving the fundings, and after that change the terminology of those who are doing the technological research, the government is ready to provide the fundings. Now what is required, the mass production. It is in the sense like the projects, if you are tied up with the industries ready to the market, that much, that kind of level of project if you are doing or proposal is giving, then you are getting it through. That the trends of the project sanction ratios also day by day are changed. So that now still the peoples are working on the photosynthesis. It is, we are now working on that microseconds. We are okay, better on nanoseconds, but the actual photosynthesis, how it is happening in the picoseconds and femtoseconds and picoseconds, how it is the naturally, but the people are trying to mimic the nature to conversion of the energies, right? The technologies are day by day increasing, but still for the food we are depends on the photosynthesis, natural photosynthesis only, not the artificial food, right? So but we are trying to reach the nature. That means that mimicking the natures But the better thing is, whatever the technologies are growing or increasing, that technology is supposed to be save the world, not to the destroy the world. So before ending into the questionnaire sessions, I want to say a few things like, is it permittable? Like, what are the research things which we are
Yes.
currently doing?
Yes, sir. Yes, sir. You can go ahead, sir.
Yeah, 1 minute. So, the solar photovoltaic work which we are doing is like in the combination with that NCPRE and IIT Bombay and IIC Bangalore, we are working on that. Our research groups are the solar photovoltaic related research, or we are collaborating with them. And then next study is like thermoelectric. Also, we are working the triboelectric, the facilities, the basic triboelectric energy harvesting testing facilities we are available. We are having the material preparation and testing studies we are having. The next level, once we are prototype is done and which is we are thinking that it is better results we are coming, then we are collaborated with the universities, China and then University of Surrey. With them collaboration, we are moving into that triboelectric energy harvesters and all, and we are working on like thermoelectric things. Thermoelectric, still we are working on the materials. We are like not in that next level of testing facilities, but in that RF energy harvesting, like we are having the complete facility of RF designs and all. We are mainly focused on the RF design for the antenna side. Now we are concentrating on the energy harvesting side also. These are all the few facilities available in our group. So like simple wet chemical laboratories and the few testing facilities also. The remaining that the combined facilities like XRD, FT, SM with the docs, those things are centralized facilities which we are utilizing. So like we are probably says that we are concentrate working on solar, tribo nano generators, and then RF, and material side we are working for the thermoelectric, and then flexible electronics and gas sensor related works also we are working. I'm going. If you are having any queries, we can go with the queries. And finally, I want to show like within 2 minutes video of a complete overview of the presentation also. If you have any queries, I'm ready to answer. Sir? Yeah.
Participants, do you have any questions? Please give the raise your hands or just type the chat box.
Thank you. Yeah, thank you, Dr. Arun Mehta, sir. So your talk is very informative. So now I request a participant to ask question. Hello. Dear participant, now you can ask question. Yeah. Yeah, please. Hari Krishna. Hari Krishna, sir. So can you unmute yourself and ask question? Hari Krishna, sir, I'm audible.
Bhatina Hari Krishna, sir.
Hari Krishna, sir, I'm audible. Hello.
Yeah.
Yeah. Hello, Hari Krishna, sir. Dear participant, if you want to ask any question, please. Yeah. Sir, Dr. Panjan, sir, can you unmute yourself and ask question, sir?
Thank you, sir.
Yeah.
Myself, Dr. Pankaj Kumar Singh from IIT BHU.
Yes.
Regarding the solar panel, so many universities are already working on that, and the solar panel are already being settled on the roof of so many departments. But my question is that, what is the purpose of those solar panels? Even they don't give the output after the power cut.
Sir, like after like power supply, it depends on the locations, or depends on the applications we can utilize. So like the people who is like not having the regular conventional power supply, for them it is mostly usable, sir. Like we can't say that the technologies or solar is not providing the power supply to the up to the mark. Yes, it is acceptable because it is less than when in the research mode we are searching, like checking, and it is giving the 23-25%. When it is in the commercial, it is giving very less efficiency and very less amount of power also. But depends on the users. Depends on the users, it is to be like used.
I think it is just wastage of money that each and every universities are doing such type of work that they are they are taking the order of the solar panels on their roof, and even utilization of the roof also.
Yeah, nowadays that sir, now the fossil fuels are completely we are running out of the things, sir. So, but the alternative source is required. Even we are spending with that, we are having enormous amount of silica source, but the conversion into the silicon and we are utilizing in the panel, then it is to be utilized for next 10-15 years, sir. If we are running out of the fossil fuels of readily available sources is very less.
Okay.
If the next years are coming, like if any, like nowadays, like coals and all very less, but the sunlight is more and more amount of it is there. Like if you are seeing that, like 5 years before in the Chennai city is completely collapsed with the conventional power supplies, but those who are availing that solar panel in their house, they are peacefully running their houses for 1 week also. It depends on the requirements, sir.
Okay.
Wherever the needed power is required, that location, the technologies cannot be wasted just like that. It can be utilized for the needy peoples.
I think it will be for the future purpose, I think.
Yes, sir.
Not for
like
the
yes, sir. Yeah. Presently, we can blindly say that okay, we are having the enormous amount of coal and oil and all, but who knows? Like nowadays, that Russia and Ukraine, if next 1 year it is continuously going, we won't get that power supply.
Okay.
So obviously, we are supposed to go with this panel only.
Thank you. Thank you, sir.
Yes, sir. In the starting years, as we said, like we dropped out that silicon. Earlier, we are the most source producer of the silicon in India, but few people are saying that okay, this is wastage and they're kept aside. But the China is start preparation, and now we are importing the silicons or panels from the China. But we are the starting producers of the silicon. We kept aside. And we are importing.
That is good. Thank you.
Thank you, Pandan sir. There is one more question from Dr. E. Manikandan sir. So he is asking how depletion layers is working in semiconductor. How depletion layer is working in the semiconductor devices.
So like depletion region is most important, sir, actually. So like in this combination of PN junction, once it is attached, why need to attach it actually? So like let us assume if you are not attached in the proper way, the light is falling into the device, free electron and holes are ejected. Just like that, it is continuously ejecting. But what is we need? Then the requirement is we need to get it in the single direction. Okay, if it is just like that, if it is moving in that all the direction, the generated electron and holes, again it is paired, again it is splitted, again it is paired. The depletion region is playing a major role on the solar cell. Once it is hitted, once it is splitted, immediately drag the things, immediately the flow of electron in the single direction and flow of holes in the another direction. For that purpose, the depletion region plays the major role. Let us assume that like if you take the water, nowadays the people are working on the hydrogen evolutions also. You can see that once it is light is fall, the water is splitted. Even it is splitted, if you are not collecting in the proper way, it is again recombined, again recombined. The depletion region plays the major role on the movement of electron and holes in moving in the single direction. That is most important. If you are failing into collecting the ejected electron and holes, the efficiency loss will be going. That is also most major thing, sir, the depletion region location.
Yeah, thank you. Thank you, Dr. Mehta, sir. It was a very informative talk about IoT. So you have clearly explained about IoT, how it is functioning. So now how people are implementing in our day-to-day life. So really we enjoyed. I hope all the participants also enjoyed. So if there is no more question, behalf of all the participants, once again, I thank to you for your valuable and informative talk. Thank you, sir.
Yeah, thank you, sir. If you are in future, if you want to contact me, and you can contact me on that my mail ID and mobile numbers.
Yeah,
We
okay,
are
sir.
ready
Shall I
to-
post your mail ID, sir, in the chat box?
Yes, sir, you can, sir. Yeah.
Okay, sir. Thank you, sir. Thank you so much, sir.
Thank you, Dr. Arun Mehta, sir. It is a very excellent talk about the photovoltaic devices on the how to use IoT things. This is a very imperative. Things in the today's essential life now. So thank you so much for being with us. Thank you so much for giving consent, sir. Once again.
Thank you, sir. Thank you so much. Thank you for the opportunity to share my information to all your participants.
Yes, sir. We'll keep in touch with you for the forthcoming, the programs and events, sir.
Sure, sir.
Yes.
Sure.
Thank you so much, sir.
Yeah.
Thank you, sir.
Thank you, Arun.